Hey, welcome to this video on imaginary numbers. And you might be saying, what in the world? I've stumbled into the wrong thing. But imaginary numbers are needed, and I kind of want to lay out the case for why they're needed and then jump into some of the problems that you're going to see. In the past, we've solved quadratic equations. Equations like this. We would, gotta change that. We would add 2 to both sides, and I'll just do this really quick because I want to lay out a case here. X squared minus 7x plus 12 equals 0. We've learned a couple different ways of solving this. Getting my a, b, c values here, and I'm populating this x with a times c, which is 12, and the b for basement goes down there, and I find 2 things that multiply to give positive 12 but add to negative 7. They're negative 3 and negative 4, so I end up with x minus 3 times x minus 4. So I factored this after I set it to 0, and now I'm going to split it into 2 equations, and I find out that either x minus 3 has to equal 0 or x minus 4 has to equal 0, and after solving, add 3 to both sides, I find out that either x is equal to 3 and then add 4 to both sides, or x equal to 4. So that was one way to solve this quadratic equation, by setting it 0 and factoring it and splitting and solving. Another way is there's the quadratic formula that you may have seen in the past. It's, by the way, x equals. A lot of times people kind of forget that part of the formula. It's x equals this. So it's finding x or whatever variable in a quadratic equation. So I'm going back up here to my a, b, c values, which are 1, negative 7, and positive 12, and I'm going to plug it into this formula. That's negative 7, which is really positive 7, negative 7, plus or minus, I'm plugging it into the formula using these values, plus or minus the square root of b squared, which in this case is negative 7. Negative 7 squared is 49, and then I'm going to subtract 4 times the value of a, which is 1, times the value of c, which is 12. All that is under that radical, and then this is all divided by 2 times the value of a, which is 1. So that simplifies to 7 plus or minus the square root of 49 minus, I do a little bit of math over here, and I find 48. That's good news because it's coming out pretty simple, and that's divided by 2. So I end up with 7 plus or minus the square root of 1 over 2. And this is 7 plus or minus, well, the square root of 1 is 1. I'm dividing that by 2. This plus or minus, you might have been wondering how we're going to deal with that. That's 2 answers. 7 plus 1 is 8 divided by 2, which is 4. All right, and I say that because here's 4. All right, and then 7 minus 1 is 6, and then divide that by 2, you get 3. All right, so those are the 2 answers that we got using the factoring method and the quadratic formula. A third method is somebody figured out, hey, if you graph this quadratic function, see the x squared minus 7x plus 12? Well, that's the same thing that we had right here, x squared minus 7x plus 12. You might notice if you stare at this long enough that 3 and 4 are the x-intercepts of this function graphed, and it matches with the 3 and the 4. So we got a graphical representation and then 2 different algebraic ways of solving for that. So, okay, so you say, well, so what? But look at this. So what about this one? I'm going to add 8 to both sides. I end up with x squared plus 2x. I added 8 to both sides, so I get plus 5 equals 0. And I identify my a, b, c values, and I go a times c is 5, 2 down there in the basement, and 2 things that multiply to give 5, but add to 2. Well, problem is nothing does. All right, 5 times 1, no. Negative 5 times negative 1, no. Doesn't add to 2. So it can't be solved. It's not factorable, so it can't be solved according to that method. Then we go over to this one and we go negative b, so we're going negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c. 4 times 1 times c, pulling from those ABC values, divided by 2 times a, which is 1 in this case. All right, so I don't need to put that there. Negative 2 plus or minus, a little bit of simplification up here. I get 4 minus, well, all this comes out to 20. Okay, so 4 minus 20 is negative 16 divided by 2, and here's where I get stuck. I'm trying to deal with this square root of negative 16. That's what I got the calculator up here for. And I'm going to go, let me find the square root of negative 16, and domain error. Okay, so it won't do it. The calculator will not do it. You cannot get a square root of a negative number, and that's the purpose for imaginary numbers, is trying to get a negative out of a square root. And then, by the way, incidentally, if we take that same expression, the x squared plus 2x plus 5 that we had, and you graph it, you'll notice that it does not cross the x-axis anywhere, so it adds to the confusion of this. Ooh, I can't go any further than this. Well, a long time ago, they figured out, hey, let's get that negative separated out of the radical. So I'm going to go over here specifically to this problem, the square root of 32. The square root of 32, I mean, I can grab my calculator, do the square root of 32, and that's fine. It's 4 times the square root of 2. So it's 4 times the square root of 2. Some teachers say 4 on the square root of 2 or 4 root 2. But I wanted to show you where that's coming from. 32 can be factored into 16 times 2. Well, I haven't, the radical or the square root function is still over that. Well, the square root of 16, well, we know that, that's 4. And then the square root of 2, well, that's a decimal, and so we just leave it in there, and so that's where this answer is coming from. The square root of negative 32, well, this can be factored. Well, I mean, if I tried to do the calculator, I'd get a domain error. I go square root of negative 32, and I get a domain error on the calculator. So what we're going to do is, a long time ago somebody said, hey, well, let's split that out. Let's take the square root of negative 1 out of that, and the square root of 32, and we'll separate this negative 1 square root so that we can use the calculator. And specifically, so we can go over here and do that square root of 32 like we did a while ago. We get the 4 times the square root of 2, 4 times the square root of 2, and then someone said, well, what are you going to do about this part? Okay, so what are we going to do about it? Well, someone decided that the square root of negative 1 was going to equal I, and I is an imaginary number. All right, and it equals the square root of negative 1. So when we see the square root of negative 1, as we do here, we can replace it with I. And it seems a little weird at first. Is that a variable? It's not a variable. A variable varies from problem to problem in terms of its value, but I is specifically the square root of negative 1. All right, and so then we're going to do a little rearranging here. This is I times 4 times radical 2. So we're just going to rearrange it. 4I radical 2. That's going to be our answer. So anytime you see a negative in the square root, pull it out. It's going to be an I, a square root of negative 1. Factor it out. It's going to get replaced with an I, and then continue your problem using the calculator or your factoring method. We're going to skip this one for the purposes of today, and we're going to go to these complex numbers. Complex numbers are just a combination of real and imaginary numbers with the I in there. All right, 3 plus 4 times the radical negative 75. Well, some people will be tempted to add the 3 plus 4, but you can't. It's 3 plus 4 times something, so the order of operations says we have to deal with this first. Well, the way we're going to deal with it is we've got 4 times, and then we're going to take that radical negative 75, and we're going to split it into a negative 1 and a 75. And then we're going to bring that down. We've got a 4 and the square root of negative 1. The square root of negative 1 is, well, that's I. I went to the calculator for a minute. The calculator's not going to help me on that. That's I. But the square root of 75, well, I can use the calculator and get 5 root 3, or I can think of 75 as 25 times 3, and the square root of 25 is 5. That's where they're getting that. 5 times the square root of 3. And then, oh, don't forget, I had that 3 plus in the front all along. I'm going to do a little bit of rearranging here. These are all being multiplied. 4 times I times 5 times the radical 3. Well, 4 times 5 is 20. The I stands alone, and the square root of 3. And now I've got the 3 plus on the front. This is the real component, and the imaginary component is this whole term right here. And it all makes what we call a complex number.